Hey class, for this lecture we are going to do a Python review and go over some of the basics that you learned in CS 1400. For this class, we will only be doing Python this week just to get you back into the swing of things. Of course, the syntax is going to change when we go to C++, but some of the concepts we're learning, such as if statements or while loops or variables, all these things carry over in each programming language. So this will kind of get you back into the swing of things with some of those programming concepts, um, and hopefully just a little bit of a review of some of the syntax you may already know. If you took CS 1400 when it was still Java, or you went to a different university and learned it in a different language, um, don't stress too bad. You may struggle a little bit this week because I'm not going to go into too much detail about Python syntax, but the idea of programming is transcendent across most languages. So if you need help with some of the syntax stuff, reach out to me. Otherwise, you can Google a lot of it. Notice that Geeks for Geeks or W3 Schools are both really good resources. And that's true for any language, even in C++. These are great resources. Don't stress too hard about it. This is just for this week. Anyway, first thing I want to go over is some of the different data types. Now, these data types, most of them also exist in C++, but for Python, notice that we have strings. Hello world, any sort of word or sentence is going to be a string. We have integers. Floats are like integers, but they have a decimal point. Complex, not gonna lie to you, I've never used this before. It's a mix between numeric and character values. Lists are huge in Python. It's just an array, and now lists can be all sorts of different data types. We'll get into that a little bit later in the lecture. But notice that this is a list of 3 strings. Tuples, which are actually very, very similar to lists. There's a whole lot of things. Dictionaries are really important in Python normally. Booleans are really important types. That would be a true or a false, or a 1 or a 0. That would be Boolean. So there's lots and lots of different types. Those are the ones that I named are probably the ones that you'll use the most. I've never had to use a memory view or byte array. I couldn't really tell you what that even is. But the basics: strings, integers, floats, lists, dictionaries, booleans are probably the ones that you're going to use the most. Now, a variable is the fundamentals of programming. You notice very quickly when you're dealing with values, you'll notice that you need to store these values somewhere temporarily. This is what we call a variable. It's used for convenience, and then as you get into more complex things, variables are absolutely essential. But notice that it's a spot reserved in memory where you store a value. So in Python, the way you would declare a variable is you would just put the name of the variable, and then you set it equal to a value. So by you putting x, that's the name that you've assigned it. This equal sign in this context is called an assignment operator. And then 4, you're assigning an integer value. What's cool about Python is it has implicit assigning to variables. What that means is the variable, by you assigning it an integer, Python knows that we're dealing with integers, and so it sets the type of this variable to an integer type. So x equals 4, and then we do y equals 3.2. So we have an integer here, and we have a float here. And then you can even assign variables equal to other variables. So I set this third variable, z, and I set it equal to x plus y. Now, what's interesting about this is we have 2 different data types here, which normally is a no-no. You can't add 2 different data types. But an integer and a float are similar enough that you can add them together. My question for y'all, maybe pause this video and try it out or think about it. But if I was to do x plus y, so 4 plus 3.2, what do you think the answer would be? So in most programming languages, Python and in C++, at the very least, when you add two numbers together like this, a float and an integer, what comes out is the value with the highest precision. So it would be 7.2 is what you're getting. This 0.2 carries over, and Z keeps the data type of a float because of this right here. Just keep that in mind. Whenever you're adding things together, the variable that displays them will always keep the highest precision. Okay, another cool thing about Python is the variable data types can dynamically change throughout the program. So notice I put x equals 4 here, so this is an integer data type. Later I say x, so I'm referring to the same variable. I'm now saying x equals Pierce, which is a string data type. If I print x, what do you think the output is going to be? The output would be Pierce. It remembers the last thing you assigned it to. So just remember, keep track of things. If you ever have to redefine or redeclare that variable and you change the data type, that data type changes permanently. So I can change it back to an integer. I would just have to set it equal to something else now, right? Okay, this is what I was saying about data types aren't able to mix. Now, something like an integer and a float can mix to a degree. It actually converts the variable to a float. But something like this, an integer and a string, this isn't going to work. If I do x is 4, y equals Pierce, z equals x plus y, you're going to get something like this. Unsupported operand types for int and string. Basically saying these aren't compatible with one another. This doesn't logically make sense. So, okay, the next thing I want to talk about as far as review is printing to the console. This is really important when we're doing console applications, which is what we're going to be doing in this class. With Python, it's a function called print. And what's cool is there's a lot of different ways, as you can see on the slide, that you can do it. The simplest way is just say print, and then in double quotes, you would write down what you want to put. What's cool is you can also output variable values. So notice here I put name equals Alice, which is a string, age equals 30, which is an integer, and then in my print here, my print statement, in the double quotes, I'm saying name, so it's going to print the word name. Then I put a colon. Then I end my quotes saying that's all I'm going to say. I put a comma here. I write my variable, which is Alice, and then another comma separating each element. I write in double quotes age, so it's going to print age, and then end it, comma, and then my age variable. So if you were to print this, what do you think would display? So the display would be name colon Alice age colon 30. Right? Here, and this is really cool with Python, similar thing, except we're using an F string. So F string is just a formatting thing that makes things simpler. It's an addition that they had to Python. What's cool about this is before your quotes, if you put an F here, you're saying that this is an F string. So an F will not be displayed to the console. We're just telling the function, the print function, that this is an F string. Then we do our quotes, and then we're writing. Notice that the whole rest of this are in quotes. We're putting name, colon, and then when we want to put a variable here, instead of ending the quotes and putting it here, we're still keeping it in the double quotes. We're just using the curly braces, and we're putting the variable here. If it's in the curly braces, Python will know that we're talking about a variable or a function or something that you're accessing from your program, and it'll display that. So in this case, it would say Bob. So name colon Bob. Um, Notice that the comma here, this is actually a mistake that I made. I just kept it in here. Good learning opportunity. The comma here is still within the double quotes. So in this print statement, the comma will be outputted to the console. So notice that that differs from up here. Up here, since the comma is outside the double quotes, you will not see any commas in this sentence. In this one, you will see a comma because it is outside the curly braces, and it has the double quotes. And since you're doing F string, you wouldn't use a comma to like separate the variables or anything. This would be if you wanted the comma to be in the string. Age, colon, age variable, which is in the curly braces, and then end. So very similar. Down here, as long as you remember the F, it should be a little bit easier maybe for you, a little bit simpler to write. Another cool thing is you can actually do some basic operations in your print statement. So down here, you're printing to the console, A plus B equals, and then a comma here to separate it, and then you're actually doing the math here, A plus B, right? Which would be 15. Another thing is this SEP parameter. This is something that's built into the print function. I've honestly never used it, but it's an option that's here for you. This is saying that you want to separate everything by a comma. So notice that the commas here are outside of the double quotes, so they will not show up. But here you're saying, I want to separate everything by a comma. So Python will go back through and place the commas in the string. So when you print it, it'll say apple, comma, banana, comma, cherry. Yeah, just like that. This is demonstrating another parameter in the print function called end. And this is just saying that you want to end and go to a new line. So you would print hello, new line, world. Okay, the next really important thing are inputs. So this is where you would input something, or the end user would input something to the console. This is really, really, really important fundamentals for programming, and you'll be doing this in your homework assignment. So yeah, what's cool about Python is in your input, in the input function, you can actually type in a string just like you would with the print. And so this will actually display to the console, enter your name. So anything you want to print to the console, you would actually write in this input. It's just expecting you to type something after. And now you would assign it a variable here, and so that value is being assigned to the variable. So if I put name equals, enter your name, I'd write Pierce. The value Pierce, that string, is now being stored in the variable called name. So then down here, we're doing an F string, hello, comma, and it's going to print Pierce. Another thing that you should remember is with the input function, you need to remember to be able to cast your variables. So notice here I put enter your age, and I put my age, and that is going to be stored as a string by default. If I want it to be an integer, let's say I wanted to add 10 years to my age, I would need to convert it to an integer by using the int function, and now it's converted it to an integer that I can work with. Okay, the next thing I want to talk about are flow control statements. So with programming, at least procedural programming, you will be going line by line, executing one line after another, and sometimes we want things to branch off. We want things to be like, well, in this scenario, I want it to go down this avenue of logic, and in another scenario, I want to go down this avenue of logic. So this is what we call flow control. Now, there are three types of flow control statements in Python. The first would be a conditional statement. This would be the traditional if-else statements. So if this condition, then execute that. Else, if this condition, execute that. So you can see it branching off by these conditional statements. Transfer statements are break, continue, and pass. That would be like, let's say we're in a loop, which I'll talk about in a second, and we want to break out of the loop. We would use the break statement. Or if we want to continue on, we use the continue statement. Pass I've actually never used before in Python, but that is another transfer statement that you can use. I'm actually not too familiar with that. And then the third kind is iterative. That would be our loops. So our for loop and our while loop are the two big ones, two only ones in Python. In C++, there's a do while loop, but we'll learn that. So yeah, this would be loops are like, let's keep executing this same block of code until a condition is met, right? So instead of writing it out 100 times, you would write it one time and then, maybe keep a variable, a counter that counts up to 100. Just keep executing it, right? Okay, so with conditional statements, let's say we have a variable, an integer variable, and it's equal to 5. We would say if x is greater than 5, notice the colon here. And with Python, remember, indentation is very important. So the fact that this is indented means that it is part of this scope. It is part of this if statement. If this was out here like that, one, it would be a syntax error, but also this print statement would not think it is part of this if statement. So remember, indentation is really important. So this is saying if x is greater than 5, print hello. Else, print world. So take a second and think what this output would be. So the output in this scenario would actually not trigger here. It would go to the else statement and it would print world. The reason why is because is 5 greater than 5? No, it is not greater than 5. So because 5 is not greater than 5, we are going to run into this default else statement and print world. Okay, so with iterative statements, once again, I talked about it, this would be the for or the while loop. So this is code that is repeated based on predefined conditions. So a for loop is you have a sequence of items, right? In Python, this could be you going through a list, or maybe you have an upper bound, and then you have another variable that increments, and you said keep doing this until that incrementer reaches that upper bound, right? Those are the two examples of for loops. So for each item in that sequence, I need you to execute this block of code. Once the last item is reached, then you need to exit that loop, right? That would be a for loop. So an example, and these are two different types of for loops here. We'll start with example 1. You have a variable that is a list data type, right? You have, and we know this because of the square brackets, and then the different strings are separated in here. So we have a list of 3 items: apple, banana, cherry. And fruits is the variable that is storing that. For x in fruits. X is a temporary variable that you are declaring right there. So you are declaring x, and then when the for loop is finished, x will go away. Will go outside the scope of that for loop, and x will not exist anymore. So this is only lives for the life of, pushed a button, for the life of this for loop. So we're saying for x in fruits. Now x is kind of like a pointer. It is pointing to each item in this list. So first x will point to apple, and then it will point to banana, and then it will point to cherry. So start with this first one. X is equal to apple on the first go around. If x is equal to banana, this is a transfer statement, continue on. Otherwise, print x. Okay? So is apple equal to banana? No, it is not. So what do you think the output is going to be? The output is going to be apple. Then it's going to move on to the next one, banana. Is banana equal to banana? Yes, it is. Okay, then we're going to continue on. We're not even going to reach this logic. We're just going to go to the next one. Cherry. Is cherry equal to banana? No, print cherry. So if you were to type this code in a Python script, and I encourage you to do so, you should see apple and cherry printed to the console. The second example is very similar, same idea. You're declaring x, but this time we're putting it in a range of numbers. So range is a function you would call. The first parameter of range is the number you're starting at. The second parameter is the upper bound where you're ending. And this third parameter is the step, meaning how many numbers are we counting by. So in this case, we're starting at 2, we're ending at 30, and we're going in increments of 3. So a 2, 3, 4, 5, 6, 7, 8. So 2, 5, 8. And then you keep going up by 3s all the way until we get to 30. And we're printing each one of those. So if that sounds a little confusing, write this little block of code in your Python script and give it a run, and you should see what I'm talking about. Okay, while loops. While loops are similar to for loops, and you'll notice when you're programming, there are times when you could use a while loop or a for loop. Either way would work. It's just kind of how you set things up. I don't care either way. I don't have a preference. If it seems easier for you to do a while loop instead of a for loop or vice versa, do it. There's not really, I think technically for loops might be a little bit more computationally intensive, but not to a degree that even really matters. So do what makes sense to you. But with a while loop, you would set a condition. So you would say while 7 or while x is not equal to 7, then do this block of code. So every time the block of code will run, and then it will go back up and it will check the expression. So is x equal to 7? No. Okay, let's do this. Is x equal to 7? No. Okay, let's do this. And then as soon as it is equal to 7, you're like, oh, it's equal to 7. We're done. And it will break out. Realize that you can very easily with this method write something that's an infinite loop, meaning if you forget to update your condition, you could like forever be stuck in this loop, and that's not good. We don't like that when that happens. So make sure you're being very careful and you're always updating your test expression. So an example here would be I equals 1. So I declared an integer variable and set equal to 1. While I is less than 6, print I. Right? So on the first go around, it would print 1. Notice that my next line of code is I'm incrementing our I variable. If I would have forgotten this line, I would have been stuck in this while loop. So after I print it, I'm incrementing it. This plus equals means I equals I plus 1. It's shorthand. So I equals I plus 1. So it'd be 2. Is 2 less than 6? Yes. Then it increments to 3. Is 3 less than 6? And so forth. All the way to 6. Once it hits 6, then is 6 less than 6? No. And it would finish. Okay. This next part are functions. Now, functions are really cool because you are just taking a block of code and you are putting it into something that just is repeatable, right? So if I put print hello CS1410 and my fingers were really sore and I didn't want to type anymore, I would put it in a function, and then instead of writing print hello CS1410 100 times, I could just call this function, right? Now functions, you can take parameters which you would put in these parentheses. So a parameter is when you're passing data into the function, into that block of code. Another thing is a return statement, which I don't have on here, but a return statement is when you want to pass data outside of the function, right? So a parameter is how I put things into it. A return statement is how I pull things out of it. Okay? And it makes code more efficient, maintainable, and readable. So definitely simplifies things a ton. Okay, the next thing I want to go over is slicing lists. This is very much a Python thing, so I'm not going to spend too much time on this. This is not a thing that you can do in C++, but it is very cool and very useful if you're going to keep coding in Python. So with a list, remember that's a certain data type where it can keep values kind of all grouped together like an array. What's cool about slicing lists is it's ways to access elements in it, right? So the first thing you would type is the starting point. Then you would do a colon and it would be the end point, and then colon and then you'd put step, which is how many are you going by. Sorry for that word salad. So basically, if I have a list and I write 1, 2, 3, 4, 5, let me actually pull up. For this one, I'm actually going to pull up my code for you. It'd be easier that way. Hold on. Okay, here we go. Okay, so in this case, if my list is 1, 2, 3, 4, 5, I'm going to go to that. I can access, let's say I want to access 1. I would actually put 0 here because in not just Python, but in most languages, you start counting at 0. So this would be index 0, index 1, index 2, index 3, index 4. So if I'm starting at 0, I'm starting here. And let's say I want to go all the way to the end, which would be 4, because 0, 1, 2, 3, 4. And then how many do I want to go by? Let's say I just want to count by 1. So if I hit start on this, I'm going to be printing 1, 2, 3, 4, 5. Or yeah, oh yeah, okay. Sorry, I misspoke a little bit. 1, 2, 3, 4, because this does count. This does count all the way. So 0, 1, 2, 3, 4. That is not including the 5. So I do apologize for that. If I put a 5 here, there you go. So this upper bound, to be clear, is non-inclusive. So if I put 4 here, it's going to go to this element and not include it. So if I go 1 above it, then it will include it. Okay? So 0, 1, 2, 3, 4. But if I want to include the 5, I need to go outside that bound, and then it will show it. Okay, apologize for that. So let's say I want to count by 2s, right? I would change the step, and now it's 1, 3, 5, right? 1, skip 1, 3, skip 1, 5. Okay? The last thing that I want to show about slicing is negative slices, meaning instead of going from left to right, I want to be going from right to left. Okay? Now, what's weird about this is element -1, because there is no -0, right? -2, -3, -4, -5. So if I wanted to access 2, it would be -1, -2, -3, -4. So I put a -4 here, I get 2, right? So that's just another way you can slice from going from the back, which is really useful. Okay. I'd take some time and maybe go through some of these and see if you can answer them. Okay, the second to last thing, it's this and one more slide, is random number generators. Random number generators are really, really important for this class. A lot of the projects we do rely on being to extract some sort of random number. Now, not to really go into too much detail, but with computers, there's no such thing as truly random. It's actually called a pseudo-random number generator, meaning it has a seed, which means it picks a random set of numbers and it goes through that random set. And then next time you run it, it picks a different seed, so a different set of random numbers, and goes through that set. And so if by chance, and it's highly unlikely, but if by chance you got the same seed between runs, you're going to notice the same sequence of numbers. So kind of a funny example is back when arcades were really big, Pac-Man was a really big game. People who played Pac-Man and were getting like world records, they started realizing that right when the game booted up, if one of the ghosts went a certain direction, they knew what the seed of the random number generator was, meaning they now knew every move after that. They knew every move the ghosts were going to make because of how it started. So they started writing down and memorizing the seeds. And so they're like, oh, ghost moved up. I know every move it's going to make now. So it's kind of a silly thing. We've gotten a little bit more complex than that with the seeding. But the point I want to make is with random numbers, if you can set the seed, meaning if you want to test something, you can put set seed, and then you can set it equal to whatever you want. And then as long as that statement's in there, you can get the same numbers over and over for testing. But anyway, a little bit of a tangent. But random numbers, with the random number generator, you want to import this package called random. So import random. And then these are the different things that you can do with it. I may have used ChatGPT for it. Save me some time a little bit. The first thing is you need to call the package and then a dot and then random with a parenthesis. This just by default returns a random float, and it's between 0.0 and 1.0. So if you just put random, it will just give you a random float between in this interval. Random.uniform means that it's once again another random float number, but instead of it being between 0 and 1, it's between any range that you want. So notice here I put 1.5 and 5.5. Random choice sequence. This is really, really cool, and I actually use this in our homework. I have a list of different fruits here. By doing choice and then in the parentheses I put the name of the list, it's now going to return one of these randomly. So instead of returning like a random number, it will return banana or it will return cherry or whatever. Random int is like random, but it's an integer. And then you would put the bounds. Notice that it is inclusive. So if I put between 1 and 10, it could pick 1 and it could pick 10. And then random range is a range of numbers. And notice once again the pattern is the starting index, the ending index, and then the step. So in this case, it could be 1, 3, 5, 7, or 9. That's pretty much it with random generators. You could get into the weeds a little bit if you wanted to, but this is really all you need for this class. Okay, last kind of random thing. It didn't really fit anywhere in the lecture very well, but I do think it's an important thing to review, is the idea of modulus division. It's an idea that we don't really use normally in math, but in programming, it's huge. And it's denoted by this little percent sign. So in math, when you divide two numbers, we're thinking like 5th grade math right now, you can get something called a remainder, right? So if two numbers don't divide evenly, you have this leftover part, and this would be called the remainder, right? With modulus division, you are returning that remainder. So if you did 8 modulus 2, you would get a remainder of 0, right? Because 8 divided by 2 is 4, it goes in evenly. So the result of 8 modulus 2 would actually be 0 because there is no remainder, right? Notice here that the modulus here is 1 because 7 divided by 2 does not go in evenly. But 6 divided by 2 does. So do 6 divided by 2, you add 1, and you're at 7. So remainder of 1, right? This is really, really, really important for different scenarios. It's hard. You kind of know when you get there. Like you'll notice. Let's say you are doing a for loop, but only want to find multiples of a particular number. You would do like modulus, right? So kind of random. This is in your try it out assignment. But anyway, that is all I have. If you guys have any questions, please reach out to me. I did include some of the stuff like installing VS Code. So if you're more visual, I encourage you to go through this, or if you need a refresher on how to install some of that stuff. But okay, good luck and thank you.